to the final talk of the day. Really looking forward to this one. So we've got Daniel, who is going to be doing our talk on building a minimal data science platform. So Daniel is a full-stack machine learning engineer and scientist. He has been doing it for over 6 years, and he founded datavaluepeople in 2020. He studied physics and philosophy at Oxford and has a very impressive portfolio after that. He also loves music and festivals and has a soft spot for UK jazz. He also loves his extreme sport and can be found surfing or snowboarding. So I'm really looking forward to this one, and I will hand over to Dan.
Wicked, hi. Yeah, I can hear myself and you guys, cool. Okay, we got a lot to get through, so I'm just gonna go dive right into it. Quickly about me, it's already done, so I'm gonna skip it. What about you? So if you could put your hand up if you currently work in the data world. Data scientist, you're a data engineer, anything, even tangentially. Okay, awesome, a lot of people. Okay, now keep your hand up if you've been doing that for over 2 years. Okay, how about 4? How about 10? Oh, a few people, nice. Okay, that's cool. That's cool. Okay, so we're talking about building a minimal data science platform. And part 1, we're gonna be, oh, this is it. Yeah, this is it. So that's it. So just build that. And yeah, I mean, we can all go home now. Cool. Yeah, okay. Well, that's pretty easy. That's pretty good. That's pretty nice and easy. So no, obviously that's not what we're gonna do. And this is my designer. My designer got carried away with some GIF in this, so you're gonna see. Okay, why not though? Why is that not an idea? Because 1, it's not minimal. Not all data science teams are gonna need the same platform, and it's not motivated. So we should only spend time building. Am I cutting out sometimes? Is that right? Is this right? Okay, let me move it. 1 sec. Okay, I'll keep my hip towards you guys. All right, it's not motivated, so we should only spend time and resources building what we need right now. Otherwise, we're wasting time and money. Cool, so what's gonna happen? We're gonna do part 1, stage setting, some intro, how to think about stuff, what we're gonna go about the platform, and part 2 is gonna be going through each of the components of the platform. So, oh yeah, so the slides are both the presentation and a reference document. So if you would like, you can check out the slides. They're just public right now with that QR code or that link, and you can follow along. But I hope you'll follow along with me and try and keep up well as we're going. But it's for also afterwards. It's meant to be both, the presentation for you to refer back to. Okay, cool. So setting the scene. There are when we talk about a data science team in this context, we're not talking about a startup that's trying to be the next, OpenAI or some specific algorithm or some specific product. We're talking about we are a data science team in a kind of like business. Like maybe it's retail, online retail, it's a legal company, it's a construction company, it's an energy company, and we're one of those data science teams that has to do a lot of stuff to bring value from data to the company in lots of different ways. So we're going to pick one type of company. It's going to be an ice cream company, because I like ice cream. So let's get a bit more concrete. We're a company, we sell ice cream. We have 6 ice cream stores around the UK. We've got 2 factories, and we make our own ice cream, and we sell other people's ice cream too. So just to ground it in some reality. So we're going to imagine we're the data science team of this organization, and we're going to grow out our platform for that data science team. Cool, the starting point for our data science team. This is it. So that's me, and a laptop, and a snake, because we're using Python code. So this is how our data science team and the platform begins. Just one data scientist with a laptop. And let's not very good if we're just out there isolated on our own. We want to interact with the external world, aka the business, and other important parts of the external world. So the orange boxes are those interactions, right? So we're going to get data from internal business data sources to do something with it. We might interact with external APIs and services outside of the business. For instance, it being sunny might be a useful thing to know when you're trying to sell ice cream. And so we might, we don't have to forecast the weather. We could just use the Met Office API to find out what the weather's going to be next week. That's an example of an external system we might interact with. And then lastly, we have the internal business systems that are going to use the outputs of what we do. So say we, predict how much cream we're going to sell in one of our stores in the next few days. We might pull the weather forecast and just make a simple model that says if it's sunny, we'll sell more. And then we want to make that available to the business to use. Maybe they have some, they're going to increase the rota for the employees because they know it's going to be busy, as a concrete example. Cool. So this is our starting point. And then when we're building this platform, we're going to go methodology for every component of the platform, every stage of the platform. So step one is going to be, there's going to be some kind of change. Like our team's going to grow, the complexity of the projects is going to increase, and then we're going to identify a pain point that is from that change. And then we're going to identify a solution, like an upgrade to the platform, to solve that pain point. So this loop is on this slide. We're going to do for each of the components of the platform. Cool. So what you should try to get out of this talk. So if you are pretty new to all this, I would suggest you try to get out a conceptual understanding of each of the components. So like what its purpose is in kind of a rough, broad sense, and how those components interrelate to each other. If you're familiar with that kind of stuff, you've used some cloud infrastructure before, you might want to start actually getting more into the details of how would I implement this in practice. And if you're advanced, please consider the nuanced trade-offs of different tech options, that kind of stuff. And please contribute your own opinions and your own experience to the rest of the audience. That would be great. OK, so now onto the platform. So this is where we're at. And you'll see that says level -1 in the corner. So it's not a great starting point. And I'll explain why. So level 0, now we get more than just me and the data science team. We've got multiple data scientists. And the pain point is we're sharing code via email or Google Drive. So please put your hand up and do be honest, have you ever shared code via email or Google Drive? Oh yeah. Oh yeah. Yeah. And how painful was it? Yeah, probably pretty painful. Yeah. Okay, so we're just going to use Git. We're just going to use a Git repo. It's going to be hosted online. It's pretty standard. It's kind of just going through the motions on this one. Cool. So this is where we're at. Now we're this. Awesome. Level up. Cool. So same situation. We've got multiple data scientists, and now we just got a Python repo. Nice. Okay. Next component. Now our data sizes get bigger, right? It's slow and painful to share data with the rest of the business via email. Hands up if you ever shared data sets via email. Yeah, okay, good. I was going to say that was not looking like the right number of people. Okay, we're going to just use like a storage bucket. We're going to use some cloud storage, right? So this is going to be the next upgrade. So this is our component slide. So this is like a slide which, again, you have to read everything on there. It's more for reference, and you can come back to it, but it represents like in one single slide, the information about that component. So the purpose of the cloud storage is to store all the outputs, results, intermediate results, and crucially, enable the rest of the business to access data science outputs directly and not have to wait for your email to come in or request it, right? And generally, I would just say, if you're starting out, just get a storage bucket and just use Parquet files and just make some convention, like use some good naming conventions so it doesn't become a mess, okay? If you're not sure what a cloud storage bucket is, just imagine it's like the file system on your computer, but you just talk to it via the internet and your team can use it. Okay, cool. This is what it looks like making a cloud storage bucket in Google Cloud Platform. Sure. Okay, great. So now we're going to level up. Cool. Now we're getting somewhere. So now we've got our laptops, which are still running the code, and we've got our Python repo, and we've got a storage bucket. Nice. Okay. Now, this is quite a sticky one, a thorny one. The change reoccur now is our data science team is working on multiple different distinct projects within the business at the same time, okay? Now we have this problem. So before we shared code via a repo, right? That was good. But now we got many repos, one repo per project. So now the challenge is we can't share code across those projects, right? I mean, you can copy and paste it, but it's kind of painful. Every time I want to make a new project, I have to set up an entire repo. I have to, like put a requirements file in there and set up the linting and what's the unit testing framework, all this kind of stuff. And there'd be different conventions. So I might be working on project 1, and I know how the code formatting should be there, and I switch over to project 2 on the same day, and they use a whole different set of standards, right? Put your hand up if you've ever experienced any of these pain points before. Yeah, okay, so still quite a lot of people. So my proposed solution in this case, it's not the only solution, is to implement what's called a mono repo. And we're going to talk about this a bit more. So what projects? I just blasted down all the projects I thought of just off the top of my head that you could do as a data science team in an ice cream company. So that's quite a lot of them, right? And there's probably a lot freaking more. So that's a lot of projects. And what do you need to deliver a project? You need a repo. You need some linting and some tooling. You need to make a dev environment. You probably need some dependency management, like a requirements file, and what you're going to use. You're going to use Poetry, you're going to use pipenv, or blah, blah, blah. You need a Docker file. You need some continuous integration. Then you need cloud infra to support it, the secrets, the cron jobs. I'll do that for every single project whenever you want to make a new one. This is really bad. This is like super, this is like really dead out. Again, my designer getting freaky with the GIFs. Okay, so the challenges of many projects. And the reason why we're digging into this component in a bit more detail is because I'm not going to say it's like unique to data scientists, but like from my experience, having worked with many data scientists and many data science teams and companies, this is often one of the most like acute and like problematic challenges that data science teams have is this problem of working on many projects in a single team. So that's why we're spending more time. And the other thing is that there's not like a really obvious like industry standard solution for it yet that I've seen. There's like a few like competing solutions, and a lot of organizations are figuring out solutions themselves. So that's why we're spending more time on this one. Okay, so duplicate project setup time and resource every time you make a new project. You can't share code across the projects easily. This is like an absolute killer. Like you end up copy and pasting your same utility code that you use to authenticate to a database 10 times on 10 different repos. And then so when someone says, oh yeah, we want to upgrade the authentication, you got to go upgrade it in like 10 fucking times. That sucks. Like that's super painful. And lastly, every project has a possibility of different standards and tools and text. And like that brain drain, like again, you put your hands up. I saw people nodding when I was describing it. This is a really painful one that is like, it's not so obvious, but trust me that it's there. Like, if you ever have done this, like, I'm juggling from different projects during a day. I have one ticket on one project, and my next ticket on another project. The mental overhead of doing that is really painful. I'm running for time. Yeah, good. Did skip me, so I better skip this really quick. Sorry. Yeah. Okay, cool. So back to refresh on the monorepo. So many projects are spawning many repos. The pain points are we can't share code across them. Wasted setup time every time I want to make a new project, and there are different conventions across them. So the monorepo is attempting to solve this. So this is a component slide for it, and the purpose is going to contain all of the code for all of the data science projects. So that includes cross-project utility code, like your code you use, the helper code you use to authenticate to a database. It's going to include the code for the actual projects, Docker files, the development environment, all of your like code quality, linting, unit testing, it's all in this one repo, and it's going to be shared across those projects. I'm going to talk about this in more detail. Unit tests, notebooks, DAGs, talk about that later. Okay, so a few important bits. Some of the options. You can roll your own, which I'm going to show you a bit about doing that. If you were a massive team, because big data science teams and companies like Twitter have this problem, they release their open source like framework for how to do this. I think if you're not like 50 to 100 data scientists working on stuff, you probably don't need it. But you can check it out to understand like an example of what you might do. And a few remarks are, this code base is like where your long-term value is built. So like you can't overdo the amount of like consideration and care you're putting into this code base. So code quality, ultra important for the long term. And generally a good rule of thumb is the smaller and less experienced your software development team is, the more monolithic, which I'll explain what that means in a second if you're not sure, you should probably make it. In a sense, the simpler you should make it, the less like flashy and flexible. Okay, so this is from a Medium article by a company called OpenDoor, and they're explaining how they do their monorepo in their company to solve this problem. And so what this is the file structure in their monorepo. Normally, people who are familiar with a Python project, you have the directory, and then you'd have like my Python module or my Python package, and then the Python code will be in there, right? So this, we have like some extra levels. So this, we have the projects directory, and within there, there is a directory for each project, right? And so that directory contains the Docker file to create, again, if you're not sure what some of this stuff is, just try and stick with me. It contains the code for that project, the unit test for that project. So like each project has its own dependencies, and the project code for that Python, for that project goes there. And then they have this lib directory. this is where you would put your cross-project utility code. So that function that you use to authenticate to a database, which is the database where everybody gets all the data for all the projects no matter what, and they all want to use the same function in all the projects, that would go as a library here, right? So like a library in the same way that like pandas is a library or like requests is a library, right? It's not a project. It's a piece of like utility Python code that you want to enable to be used across all of these projects. So then, when somebody says, yeah, we need to update the authentication function to the database, you don't do it in the code bases of 10 projects. You just do it once in the library. People, I see some nodding. OK, cool. And then lastly, you have like the tools. So again, this will be stuff like, if you're going to use the black formatter or using MyPy to do like type checking, you only have to define that stuff once. You define it in tools, and you use it across all the projects. Cool. OK, I actually was going to say, I couldn't show you an example that we had built, because we generally only build them for clients, but we actually just in the past week started building one for an open source project we're doing. If you really want to check it out, see it, and you can even ask us questions there, there's a link here to it. This is for a automatic classifiers for peace, doing like social media analysis for peace builders who are trying to understand how conflicts play out online in digital spaces. And we're setting up a monorepo there so that the researchers who are going to be doing different kinds of research, it's all going to be in one repo, and they don't have to rebuild all this stuff. They're just going to make a directory in the experiments, which is the equivalent of the projects, and then they just do their experiments in that directory, and they get to share all of the same utility stuff here and all of the dev environment, that kind of stuff. So if you want to check it out, you can. Cool. OK. That's the most complex one, so good job for still being awake. Nice. Great. So level 1, level pain. This is painful. You have many Python repos. Nice. Relaxed. You have nice one big repo, and we don't have all these overheads and frustrations that we had before. OK, cool. Some simpler ones. Cloud compute, the change. Now our data science team is getting more sophisticated, and we are using using models in our projects that are much beefier and serious than our old baby models we used to use. So we don't just want, now our models need loads of memory, maybe they need massive CPU power, and maybe they even need stuff like GPUs. The pain point is, if you need that and you're running it on your laptop, it's painful. Put your hand up if you've ever run something on your laptop overnight. Put your hand up if you've ever run something on your laptop that took 7 days and you had to leave it and just really hope the power didn't turn off. Yeah, it's done. Cool. OK, the solution, let's just use a cloud server. Great. The component, this is a component slide for that. The purpose, you want this component just to run the code you give it, tell it to run the code you give it. That's it. Nothing more, just run my Docker image with the command I told you, and that's all it does. And again, just to be clear, this is the bit that interacts with your data sources in that compute engine. So some options. I think for data science, serverless is really, really great, because often you're doing batch processes. You're not hosting a website where you need to be up all the time. You're just I need to crunch a ton of data, so just spin up a server, crunch my data, make my outputs, and then turn off, right? And that's what serverless means, is that it's not a computer you have available the whole time. You just say, hey, I want to run this job, and they go, great, we'll find you a computer. They give you it, and then when the job's done, they take it away from you. This one's really nice to use. This one's pretty painful. Some consideration. So the length of the process, that's consideration when you're picking which of these to use, the memory needs, the compute power needs, the GPU, or even CPU fancy stuff. So again, consider what your job needs, and then look for the right tech that matches that. Generally you want it to be as simple as possible. Cool. OK, so another level up. Now we've got bigger, so you can't see the title, but this is level 3. Now we've got our data science project monorepo, our storage, and sorry for the typo, and also it interacts with the compute engine, right? And now the laptops aren't really there, because the laptops, we don't really need them, right? The laptops are just there for you to edit code and to push code onto a compute engine to run stuff. Cool? And just to point out, so now your compute, your server is pulling data from your databases and is talking to the, the weather API to get the weather forecast, and then your business is still talking to storage to get the outputs, say the forecasts, right? The forecast for how many people do we need to, have working in the shop on Tuesday? Oh, well, it's going to be 28 degrees, so let's double, we need to make sure we have some more staff, as the example. Cool, OK. The change, now we started using cloud compute. So the new pain point, code that runs on your laptop, it breaks on the server. Put your hand up if you've ever encountered this lovely pain point. Great. Probably anybody who's ever used a server and tried to run code not on their computer has encountered this. Very, very frustrating. It's all working nicely, and then suddenly it stops working. So the solution is, let's implement some continuous integration, continuous deployment, and use Docker and something like Cloud Build, but any kind of build process, any kind of build service would do. Cool. What is a Docker image? I took this from you-know-who. A Docker image, I asked you-know-who for an answer to this. A Docker image, that's ChatGPT, just to be clear. A Docker image is like a lightweight shippable box that contains everything needed to run a piece of software, making it easy to use across different computers without any setup hassles. I thought that was pretty good. So, when you write a computer program, you normally write actually a text file, right? Like a Python file is just a text file. But there needs to be, there obviously something more than just a text file for a computer to be able to run it. So what this does is it wraps your text file, your computer program, up with those things it needs to run. So, which might be other text files, and then it might be stuff like, I don't actually know how it works the whole way down, so sorry. But yeah, it's like a little encapsulated computer that you can ship around and get other computers to run. Yeah. So here's the component one for that. So it takes your code base. So this is like the build component. It's going to take your code base. It's going to build a Docker image out of that. So take your code, take what the code needs, and combine it together into a nice little package. And then it's going to run the continuous integration on that image, check that it's passing the linting, check that it passes the unit test. Whenever you see CI, you can just think of it's just checking, is there any screw-ups in there, right? And then it's going to push that image ready for use by the cloud compute. Okay. Tech options, again, there's not that big of a difference here. They're all pretty similar. This is pretty much the only one you're going to use when it comes to containerization. There may be some competitors, but when someone says like a container or like an image, they're generally talking about Docker. And some remarks like doing containerization is really now like the de facto standard in the industry for how you make programs run on a different computer. So it's a really, if you've never like interacted with Docker before, it's such a valuable skill to use for your career, for sure. Like you're going to have to use it at some point. So cool. Okay, that's what a Docker file looks like. If you've never seen one before, from this image, which someone else already made, I'm going to extend it. I'm going to get my requirements file in there. I'm going to install the requirements. Then I'm going to copy my Python code. You might see that before. It's just copying the code from your project inside the image. And then you're going to run this, which is just a little web server. You don't need to do the details, but just in case you ever see something that looks like that, it's a Docker file. Okay, this is what a GitHub pipeline workflow specification looks like. They're nearly all of the services that do this. It's nearly always like some kind of YAML document, and you're really just writing like a list of instructions. So, okay, get the code, check out the repo, log into Docker, build the image, and push it to Docker. So, this is one from an open source project we did, and it's not building an image and pushing it. It's like it's not a project, it's a package. So we want like other people to use it, right? So it's a bit different. We're just running the unit tests and the linting and stuff on the code that's in there. So yeah. Okay. Nice. Now we're getting flashy. So our code, when we push a change, it's going to trigger a build job. It's going to get all that code and it's going to build the Docker images. They're going to go to this container registry, which is just like a file system in the cloud that stores those shippable boxes. And then we're going to tell our compute, hey, run my Docker image with this command. And then it's going to do the jazz. Cool. Okay, the next one. How are we doing for time? 10 minutes left. Man, we're doing good. Nice. Okay, infrastructure as code. So now the change from the last one. Now we're using a lot of cloud infrastructure. So that's quite a lot. Now we've got like 4 big components. They all need to be configured. They all need to like have their permissions set up so that they can access the stuff that they need and talk to each other and not like be publicly open to the world and have some terrible like security problem. So even though there's only 4, blue shapes, it's actually like a lot of junk going on there, right? So the pain point is this is hard to manage. So there's no record of what's there. And there's no change approval process or visibility. So put your hand up if you've ever experienced this pain point. So that might be something like, oh yeah, I was gonna, oh, I wanted to go use the cloud bucket, but then you couldn't find it, and that's because Jimmy deleted it, and you didn't know. So this is a big pain point. Once you get to a certain amount of like cloud infrastructure, this is going to bite you for sure. So the solution, and this is pretty like standard industry solution, to provision and maintain your cloud infrastructure using technology called infrastructure as code. So the clue's in the name. The purpose is it is a code specification of your cloud infrastructure. So instead of going through going on the AWS website and clicking, oh, make me a cloud bucket, instead you specify it in a code file. And what this technology does is it reads that code file and it will automatically provision it for you. This is like, from what I'm seeing, pretty much the standard these days, and a good one to adopt if you want to adopt something. There's some other ones. This is probably the biggest remark. This is, if you've never done this, or no one in your organization's ever done this, it will be a big hurdle, because setting it up is not super trivial, and generally it's just like a different way of working, but it will pay massive, massive dividends down the line. Like, you will be doing yourself the biggest cost-saving exercise ever if you're operating any amount of complexity of cloud infrastructure and you're not using it. Start using it, will pay the dividends within a year, easily. The ideal is you have a DevOps team in your company and they support you in doing it. So you don't really have to like manage it all. They're the experts. You just use it. Wait, what did it say? Yeah, this is also a good one. Like, forget it. It's cool. It was going to take too long. This is what a Terraform file looks like. So it is. This is the code specification of what you want in the cloud. So the only thing this is telling you is, I want a Google Compute Network, like a VPC. And then what Terraform does is it's going to read that file and go like, okay, yeah, you want a VPC, right? And then it's going to go and it's going to talk to the cloud platform, and it's going to say, yo, like, what you got? And the cloud platform is going to go, I got nothing. And then so Terraform's going to go, okay, there's a mismatch there. Like, the user said in their file they wanted this resource, and it doesn't exist in the cloud. So then it's going to make you a nice plan like this, right? Terraform will perform the following actions. It will create this resource, and then you get to say, it was totally that plan. So it'll say, hey, I'm going to do these things. I found the mismatch between what you said in the code specification and what's in the cloud. Remember, it's talking to the cloud for you, right? Does all of that for you. So it's going to see that difference and say, hey, this is the plan that I would do to make the cloud be what you specified in your code. And then you say, great, go do it. And then it goes and does it. So super valuable, useful tool. Once you get into a certain amount of cloud infrastructure, once you start feeling that pain point, it's time to invest in doing this. Cool. Okay, so this is where we were at before, and now it's what we look like. So we got our infrastructure as code repo, and everything that is in this cloud services box is now no longer controlled by someone manually clicking on the web page. It's entirely controlled by the code that's in this server and the infrastructure as code service that is going to make your code here, make what's in the cloud match what you want and said in the code. Okay? Cool. Okay, we're getting close. We're getting there. Okay, orchestration. We want to run jobs and pipelines repeatedly or overnight. The pain point. Manually triggering jobs is error-prone, annoying, and waste time. Put your hand up if you've ever gone to work and then for extended period, and every day at 9 a.m. you put some command in a computer to run something. Every afternoon you say, oh yeah, sales wants a forecast, so you run it, right, every single day. The solution when you're having this problem is to use an actual system to trigger those jobs for you, right? Like, I want something to run 9 a.m., I could wake up at 9 a.m. and press the button, or I could set up a computer to do that, right, to trigger that at 9 a.m. Cool. So this component, the purpose is it takes DAGs. It stands for Directed Acyclic Graph. So you can just think of it as like one-way pipeline of steps. And then it schedules and triggers those jobs. It does stuff like backfilling, failure recovery, and it records the job runs. Here's like some of the classic tech options. This is like the old school one that people powered and probably still powers like millions of important stuff all around the world. But like generally, you don't have to put yourself through the pain of that. You could use something nicer like Airflow or Prefect. And Airflow used to be the classic like gold standard, but now there's more competition in the space. Cool. Yeah. So this is what a DAG looks like for making a pizza. So step 1, you prepare stuff. Step 2, you apply tomato sauce. And then all at the same time, you add all those ingredients, and then you prepare the oven, then you bake the pizza. So my designer, who was helping me with the slides, actually is Italian, and he had a problem with this slide. Anybody think what the problem might be? Yeah, so he didn't really agree with that you could add cheese at the same time as adding ham, olives, and mushrooms, and actually there was an order there. So this DAG was totally wrong, and he wanted to make it pretty clear, so yeah, okay, cool. This is what a Python file that specifies an Airflow DAG looks like, just in case you ever see one. So with this DAG object, make a task, and connect these 2 tasks together in an order. That's what's going on there. This is the Airflow UI. So if you ever see this, so this is that pizza DAG, but a real one, and it just does 2 things. It don't know where it says. Oh yeah, it writes a file and then it reads it, right? So it's pretty simple. But just so you get the sense of what you're going to be looking at in the real world. Okay, nice. So this is it. Now we've got everything we had before, but our build system now does 2 things. It makes those Docker images and it pushes them ready for the compute system to use, but it also updates those specifications of what jobs we want to run and when they should run, right? So, every day at 9 a.m., produce the sales forecasts for each of the 6 stores in our business. And instead of me having to trigger it, and sometimes I forget, it just happens automatically. And instead of me triggering it, I just come in and I look at my Airflow UI and I just check, yeah, great, it ran perfectly, cool. And again, that's going straight to storage. And the rest of the business, you can tell them, hey, it'll be there by 10 a.m. for you, right? Cool. So how do we do? That's it. That's the platform. Nice. We made it. How do we do? Minimal. Was it minimal? I'm going to say pretty good. It was kind of what we needed. There wasn't too much extra fluff there. Was it motivated? Again, we tried to pick a pain point that at least somebody in the room had put their hand up to say, yes, I'd experienced that, and then solve it. And the last bonus one is that it was actually modular. So we went through this in a certain order, but you don't have to build it in that order, right? So, and this is a big benefit of building a platform in this way, is that you can mix and match, and what you would do is you would solve the biggest pain point first. So, maybe storage isn't your biggest pain point. Maybe the biggest pain point is you really are doing big bag models, so you just need to have cloud VMs straight away. Or the biggest pain point is managing our cloud infrastructures off the rails, so go straight to use Terraform. That's your biggest priority for improving your platform. So this is a really important big benefit that I didn't say upfront, and that I hope it's clear that you could have done what we built in any order, right? Okay, cool. This is just a reference slide. So if you look in the slides and you want to come back, it's just one slide for the whole talk. This is the old ugly version. And okay, before anyone asks, what about off-the-shelf platforms? So there are companies, open source frameworks that are intending to be your one-stop shop. You adopt this one technology and you have a data science platform and it does all of it. So here's some options you could check out. Some of the pros. It will give you, because you have to do it their way, it will give you direction and structure. So you'll have to make less decisions because they will have made decisions for you. There might be less overhead to adopt it than building that whole platform we just spoke about. And it might have really powerful features that really, really fit your use case and just accelerate your data science work. Some of the cons, again, the lack of flexibility. You have to do it their way or no way. This is a big one I often see. It's just often for smaller teams, it's just massively overkill. They might not need that whole platform we just built, so they can just pick the bits they need. But if you're adopting one of these, you might have to do a ton of overhead that, again, isn't motivated and isn't required. And they often don't follow this, where you can mix and match modular tools. Okay, great. That was it. Yeah, just really quick. If you want cool designs, this is my designer that I work with. He's super lovely. And that was it. Yeah, nice. Nice. Cool.
So good, so good. What a way to bring it all to life. Loads of energy. That was absolutely fab, Dan.
Awesome.
I'm sure there was something in there for absolutely everybody. But are there any questions? Any questions out there?
Yeah, do you want to just shout out? Yeah.
Yeah.
So the question is, well, first of all, I'm kind of like coming from, I have kind of like two jobs. I have it in a commercial setting and also I'm doing charitable work. And I was wondering, is there a difference between some like the two settings? Or is that kind of like your recipes have been measured?
That's a good question. So in Data Valley People, we do a lot of like, just working with big companies, like doing data science for them. And we also have a partnership with a nonprofit for the past like 2 years. And I don't think there was really that much difference other than, it wasn't that much difference. No, I think, they're both trying to solve, generally you're trying to solve similar problems just with maybe a different end goal. So yeah, I don't feel that big of a difference. At least not to do with the software development side of it. Yeah. Yeah. Sure.
Like, let's say you join a company and they're doing things completely differently, and you know that.
Yeah. Cool.
Sorry.
I guess my question is, how would you get buy-in from your manager or stakeholders in the company if you wanted to build a data science platform like this one?
Okay, cool. So I'll just recap. So that was, if you join a company and they already do stuff, or they're already just accepting the pain points that they have, and you see an opportunity to very much improve the efficiency and effectiveness of your data science team by investing in one of these components or something like this, how would you persuade or bring on board the stakeholders or the rest of the business? And I think, again, in my experience, it's very much focusing in on that pain point. So if you can effectively communicate that pain point, and even better, if you can do stuff like get some data about that pain point. So an example might be, you might work in a company and they might be running processes on their laptops that take hours. And if you were to calculate an estimate of how much time you would save by just running this on a cloud computer, and you can put an actual numerical value on the returns on the investment you would get from improving your platform, right? So I think it's about how you communicate it, and the most effective ways I've seen it is if you can make it like evidence. I guess we're like in the data world anyway, so that kind of feels natural to do that. Another example might be you might have like a continuous integration build system set up, and it might be super slow and janky and painful, and it takes like 40 minutes for every single build, and or sometimes it breaks for no reason. And if you can try and like pull that data out of the build system and analyze it, then you can say, yeah, this is really, really causing tons of waste, and we could do this and probably reduce it by this amount. Yeah.
Thanks, that was a really great talk. So you recommended the use of monorepos. So I've heard people have your approach, and I've also heard people say every repository should only be one thing. You should be able to explain, in one sentence what one project does. So you have at one end what you're saying, where you have everything in one go. At the other end, you could have a microservices approach, where, say, one of your utility package was data generation, and you want other people to just use just that bit if they wanted to, and you could just have that be one package, like a pip package or even like a Lambda function. So I was wondering, what are the trade-offs in making that choice? Which approach to take?
Yeah, great question. So actually, the monorepo slide is that section is the bit that my team, when I've had feedback from them, is like the bit they have the biggest complaints about, because I'm kind of pitching it as like, this is the solution, and they're like, there are other solutions for solving that same pain point of having multiple projects and sharing utility across. Another big contender for solving that would be to do something like set up an internal PyPy server. So when you're using Python and you write pip install something and it talks to the internet and gets the code, you set up your own version of that, where someone in your business can say, pip install, ice cream utilities, and the code from the company, but it's private, so no one else outside of the company can use that, right? So then you can share code across projects in the same way that Pandas is shared across bazillions of projects around the world, and that's like an alternative way where then you would have your projects would be individual repos, but the way that they would share code is you would publish internally utility packages that then would then be installed by your projects. So I think on that slide, So I think the trade-off there are, the trade-off I think about with all the monorepo stuff in generally, which is also how you design an individual monorepo. You could design it more flexible, less flexible. And again, with the PyPy stuff, that would be quite an extreme end of flexibleness. So you could publish your own, then you have all the flexibility of like versioning, publishing different versions, different projects using different versions. There's a lot of flexibility there. And I think generally it's a good rule of thumb to think the more flexible it is, the more complex it is, and the more difficult it is to maintain, and the more difficult it is to get right. And so I would consider where your team is at in terms of both its size and its experience. So the smaller and less experienced you are, try to make your solution to this problem simpler but less flexible. So like you can't do as much fancy stuff with it. For instance, you might not do the internal PyPy server thing if you're like 6 people. If you're pushing like 20, 30, 40, and you've probably got like a lot of software engineering expertise in the team as well as all the data science expertise, then you might want to start going for some of the more like very flexible and powerful, but come with responsibility or something like that. You know what I mean? Like come with all the overheads and the requirements to maintain it and effectively do it, and not let that actually then become a pain point itself, right? Yeah, but that's a really good point. Totally. Yeah.
Thank you for connecting the dots. From a storage standpoint or in ETL standpoint, we've not covered like particularly in details of what would be ideal solutions or tools for kind of ETL plugins. Would you always recommend like a Python script that would do the job, or would you also recommend some cloud-based tools?
Yeah, that's a good point. So let me just go back here. Okay, so this has like an implicit assumption in it, which is that in an ideal world, where the data science team, there's a really, really wicked data engineering team, right, that sits kind of upstream of us. And the data engineering team would be this box, like this one. And so when we wanted to get data, we might have to do a bit of post-processing, but really we've just got, great numerical representation of the business sitting in database tables ready for us to get when we want it, right? Because the data engineering team have done all that hard, super messy work. So that was like implicit in the talk that I snuck in there. But does a lot of this stuff apply for doing data engineering? I think definitely also, having done a lot of data engineering as well. And yeah, I guess, again, there might be differing needs or differing like acute pressures if you're doing more data engineering than if you're doing more data science. So that's again why I think like, and often put your hand up if you're a data scientist or you work in data science, but you do a lot of data engineering. Okay, so yeah, I feel like that's another reason why that like the more like modular components and the mix and matching. I'm a big proponent of, is because if you're a data science team and you get given a project to do and actually it requires a ton of kind of data engineering heavy lifting, then you might be able to put in, say, maybe you'd have to collect a ton of data from like a live service, but the data engineering don't want to do it, but you need to make the project work. So you're like, oh, well, we need to use like a streaming, buffer like Kinesis or something. You can bring that into this project, as another component in there in a sense. So, but yeah. Yeah, good question. Yeah, it's good to highlight that I snuck the data engineering team in there. Yeah, thanks.
Any more questions for Dan? Yep.
Yeah, I can repeat if you want to tell me.
I'm assuming that you have a system like this in your company.
Do I have my company?
Do you have a system like this in your company?
Yeah, I've built similar stuff to this like many times. Yeah.
So what are your pain points when you get to this stage?
What are my pain points? Oh, that's a good problem. Let me have a think for a second. Yeah, no, there definitely are. Okay, what is a big one is this section that I skipped. So I think we got time. I skipped it because it's a bit of a barrel of worms, but I've gone too far. Oh no, here we are. Yeah. Okay. So this is sometimes the problem, right? Is that I've set that again, another implicit hidden kind of assumption in this whole platform is the following. So I'm going to pitch it to you. Okay. So projects, all these projects, remember all these projects? All these projects, this is my pitch. Okay. That they sound different but really they're just the same game. And the game you're doing is this. Step 1, you read some data from a business or external system. Step 2, you compute something static off that data. Step 3, you make that available to the business, right? This is my hot take on what data science is. This is, again, the reason why I skipped it is because my team, when I showed them this, they were like, that's like way too oversimplifying some of the problems in data science, right? So a clear example of this would be you are not doing like batch predictions to forecast, for instance, what the amount of customers are going to be at a given shop in our business. What if you do need live prediction, right? What if you need something like a customer comes in and they, I'm trying to think of a good example. What if they come in and you have a chat bot and have a conversation with them and you want to suggest to them, their favorite ice cream flavor to try, right? We can't like batch pre-process that. There needs to be some kind of live interaction, like live serving of an interaction for a customer there. And this platform doesn't have that capability in it, right? So another example would just be, okay, maybe you just want to set up like a prediction endpoint in your company so that anyone in the company can use one of your forecasting models to forecast something that they want when they want to forecast it. And again, this platform is very, very like batch orientated. So it's very much about like batch computational stuff. So you would need some, you'd have different complications that I haven't even touched on if you wanted to put like, say, a model live on the internet that anybody then could go talk to, right? So, yeah, maybe that's like it. Oh, sorry. I'm not giving anybody too bad. So in this case, a customer comes in and they want to predict them an ice cream flavor that they're going to love. Instantaneously at that point, that capability isn't in here anywhere. So the capability that is in there, though, is the model that makes that prediction can be retrained and tested and verified and do like all the stuff you need to train the model. And then it would be an output that then another system could take the live, serving bit, could then take that model and use it. So, does that kind of answer? Okay. But yeah, when I've done this before, that's a common one. Is like, what if I want to do live serving? And yeah, this doesn't do it. So, but I think you can go a long way in data science without doing that. And yeah, I don't know. Yeah. Cool. Is that it?
Brilliant. If that's all the questions, then we'll wrap up and say a massive thanks to Dan.
Thanks very much for joining in. Cheers.